Guys, my name is Neil, and what I want to talk to today is how I made one of these devices. Now, in a previous video I showed you how to use this indexing device in the mill to mill 4 flats on a piece of shaft. When I say in a previous video, I mean in my only previous video. And just to recoup quickly, and it's all shown in detail in the video. A piece of bar is mounted in the collet, and the indexing device put into the into the vise of the mill. One flat is milled, rotate 90 degrees, mill the next flat, rotate 90 degrees, mill the next flat, rotate 90, mill the last one. So you can do 4 flats on a shaft, or 2 flats for a spanner flat, or even one if you so desire. And what is useful is to be able to put 6 flats on the end if you're making a bolt and you want to make the bolt head. So in my previous video, which was only yesterday, I made the comment that I intended to make the hexagonal version, and last night a good friend of mine in Norway made the comment that he would like to make one of each. So I thought I'd set to and finish the hexagonal version. So I've done that in this video that we're watching now, and it didn't take very long. It's probably only half an hour from start to finish. So this is the hexagonal version. I've got that. You need to put the collet into the nut before you screw the nut onto the thread. So that's the finished hexagonal version, and again it's mounted in the vise and indexed either 6 times for a 6x flat, or twice if you want 2 flats, or any combination thereof. So having both indexing devices, you can do 1 flat, 2 flats, 3, 4, 5 or 6. You'll notice that I've got a piece of wood on the table of the mill, and you would have noticed yesterday that I didn't have the piece of wood, but whenever I put something down on the now I've got the threading tool, 60 degree threading tool, set up on the tool post, and if we have a look at one that I made previously and screw the nut right on, we'll see there's about 5 mils clearance for a run out groove. So we've got just over 5 mils there, so we've got plenty of room for a run out groove on here. The thread only really needs to go to about that point, so we'll machine a run out groove just past there, so that we've got a bit of room for the tool. Put a bit of extra lighting on just to get this looking a little better. I won't do it with a parting tool, I'll do it with maybe I will do it with a parting tool. I'll just move it out of the jaws a little bit further. you're doing that by eye, and it's a bit hard to work the lathe when the camera's in the way. Okay, so we'll install the threading tool, and we'll just get it up to square it up on the work here. We've got a convenient flat face to use. I would normally square it on the chuck, but and we'll just set the lathe to 1.5mm pitch, which is, yep, that looks pretty good. Alright, so I'll wind this back to 0, I'll zero the cross slide, and we'll go again. We'll speed the lathe up. Right, so we'll back to 0 and we'll take 0.1. Take another 1/10, 0 the cross slide. Got 1 revolution, reverse. Then 1 revolution and another 1/2. Just check that pitch again. Yep, that's spot on. And another 1/10. That 1 revolution. Right, we'll start taking smaller cuts now. A bit too small. Zero the cross slide. Back to zero, half a tenth, zero the cross slide. Back to zero, and we'll take an even smaller cut this time. We're getting fairly close, I think. Stop the lathe there and we'll just try the nut. That's looking pretty good. And no shake. Right, so now we want to start boring our 8° taper, and it just so happens that I still have the cross slide set up on 8° from the previous job. Which is why I left it there. I'll just take the gear lathe out of back gear. Right, I think that's probably a better view. The threading gears out of gear makes the lathe a bit quieter. I'm using a tungsten carbide tip here, which is getting a little bit tired, and I probably should be using a tool steel cutter. But Now, I'm also doing this in the 3-jaw, and I am aware that it would be better if I'd set the billet up in the 4-jaw and clocked it, but this 3-jaw chuck has actually got a pretty low error. It's not right on the index. So the final job will have a run out of perhaps a thou or two, which for the end use is probably good enough. What it means is if I put hex threads on, hex tops on fabricated bolts, will be a thou or two will run out, which is livable. And I'm cutting this by hand and trying to get a nice smooth continuous feed here. The lathe can go faster, but it's a bit noisy and the ends are not quite as smooth, so and at the moment I'm not doing any cuts on the way out. I'm doing all the cuts on the way in. Check the diameter of that with the diameter of the other one. 19mm, right, so we've still got at least another 5 to go. So I can probably take bigger cuts and stop pussyfooting around a bit. Cutting a taper, there's no going back. What is done is done. I don't know what this metal is, this steel. This is a bit of hex I've had for probably 10 or 15 years in the workshop here, but by the way it's cutting I would say that it's leaded. Lines in there. That's neat. Not feeding it evenly. I don't have a power feed on the compound, unfortunately. Now the way I set the compound up, I actually put one of the ER collets between centres. I machined up a new centre in the headstock and put it between centres, between the tailstock and a brand new centre on the headstock, and then put an indicator on the compound and adjusted it for 0 run out from end to end, and it did. It took me quite a while to get it right, but I did manage to achieve a very good indication. So I haven't shifted the headstocks, I haven't shifted the compounds since I did the last one, because I always had this this new one in mind. I'm taking this pretty easily because you can't put it back. I know that it's still too small, but 21, and we want to bring it out to around 24.5. And yeah, I can hear people saying, but you can't measure the end of a taper with a pair of calipers. Yes, you're right, but you can get a fairly close idea. see how we're going here. Right, so still got a way to go yet.